I'm going to do a demo of the theoretical ideas behind Antodicton and how it relates to the config file and what you see when you're debugging stuff. So I'll just use the time knowledge module to demo this. So operator precedence parsers in the past were used to analyze arithmetic expressions like 1 plus minus 2. In this case, plus is an infix operator and minus is a unary prefix operator. So to configure an operator precedence parser to parse this, you'd have to tell it what are the operators and what kind of operators they are. So in this case, plus is an infix operator. I'm just going to use Prolog notation. So plus is an infix operator. It takes 2 arguments. And unary minus is like a prefix operator. And the other type of operator is a postfix operator. In this case, I don't have that, but it's easy to understand what that is. And the other parameter you need for the parser is the priorities of the operators. So in this case, unary minus is going to be first, and then the plus. So if a operator precedence parser, we're going to parse this thing, what it would do is it would, first we have the constants. So these are constants. And then the first thing it would do is find the operator with the highest priority, which in this case is unary minus. And it would apply that operator, and then you'd get, you take the number 2 and turn it into the number minus 2. And then it would pick the next highest priority operator, which in this case is plus, and it would apply that, and then you get minus 1. Is that right? Yeah. Okay, so that's all it does. You need to know what the operators do when you apply them and their priority. And then you can parse this expression. So what I did was I found a way to generalize this so you can parse English. So in 1992, I think it was, I was using Prolog and I thought of this sentence: a cat went to the store. And you can actually get, Prolog lets you define your operators and their precedence. So you could use it to parse this sentence if you want. So in this case, va is going to be a prefix operator. Went is an infix operator. And to is a another prefix operator. When I normally do to, one of the generalizations is that when you apply an operator, the result of applying an operator can be another operator. So normally for 2, I would make it a prefix operator that evaluates to a postfix operator, but I'm not doing it for this because it doesn't need it. But that's one of the generalizations. And then you'd have to specify the priorities. And priorities would be the, to, went. Yeah, and so then if you're going to parse the sentence, you do it the same way as before. The constants, this is a cat's a constant, store is a constant. Then you pick out the highest priority operator, the. So I apply the, and I get this. Then I go and pick out the next highest priority operator. Well, it's another the. So I do that, apply the to the store. Then I'm obviously not showing the value, but this is how it's applied. And then I pick the next highest priority operator, that's the to. And then finally I pick the next highest priority operator, that's the went. Okay, so then how does this relate? So then in the config file, you don't see this FX stuff and this priority thing stuff. You don't see that explicitly done. You can, but I don't normally do that. You only need to do that if it's needed. Anyway, so you see this kind of thing. So how does this notation work? So I'm using this notation for 2 things. It's defining the priorities of the operators and the type of the operator at the same time. If we were to relate it to this example here, how do I want? So I use the, so in order to mark an operator, there's 2 ways to do it. You can either use the greater than less than sign or these brace things. So if you use the greater than less than sign, this marks an operator. So that means I've said va is an operator. Yeah, but it's a pass-through operator. So that means the result of applying the va to the cat is a kind of cat, and it's not a kind of va. And the importance of that is because it's used to determine the types of the arguments that go to the operator went, this operator here. So I need to know if this operator is a pass-through one or it's the result of applying the operator as the actual operator itself. So with determiner, currently what I'm doing is just adding markers on the cat object. And that's why it's sort of just used to modify that rather than be the thing. So that's this notation, which is pass through. And then what you need to do is mark the arguments with, in order to tell the arguments from the operators, the arguments have to be surrounded with parentheses. So I know that that it's an argument and that this is the operator and that all the stuff in between here. So that lets me know that the is a prefix operator whose first argument is of type store. The result of applying the operator is a thing of type store. For this particular notation, if you don't, like, store is actually a constant. So this just is, it's just a nice name. It allows any type of things here. Okay, so that marks the. So I've done the. So then I have to do the to. Well, what kind of operator is to? Currently, I'm making them not pass through because the verbs, it kind of acts like a type marker in the context of the verb went. So in this case, the result of applying to the phrase the store is going to be, so this to is actually, oh, I forgot to mention that. So I did mention that. Operators have multiple levels. So this to is actually internally represented as 2, 0, which is the operator with the ID 2, which is at level 0. So the result of applying the operator to, one of the generalizations, will be that you get a new operator, 2, that's at level 1. I've used that a lot, so it's actually very cool. I'm not going to say the details here, but you can see it in the code. Yeah, so that's the result of applying the operator to here. And then, so we want went to be an infix operator. So we mark it like that, make sure the arguments are wrapped in parentheses so we know that they're the arguments. And then because of this, then I know went, in this scope, went is an infix operator that takes an argument of type cat, and, well, actually of any type, and on the left side, an argument of type 2, level 1 on the right side. So that's how that would be marked up in this framework here. So I'm doing, I'm going to use the time knowledge module. So you can say use 24-hour format if you want. Oh, I should mention that. So if or automatically, when it creates the operators, it has to map words into the operator definition. So if you define it like this, it will create an operator with an ID the, and it would also map the word the into the. So if you wanted to use different words, you could do le or whatever, le, la, whatever. You could use that. That specifies what words you want to map to the. Oh, and then you have to add the. And so if you don't want the word to map to the operator, you can just do this kind of thing. So it's just a shortcut for, instead of adding stuff to the words array, you can do that here. Anyway, so this, at this point, this defines the operators, what the types of the arguments that are, and the priorities of the operators as well. Yeah. Okay, so I'm just going to demo it with this use the time format. Oh, so use the time format. So here we've defined operator use, and there's a count that's a prefix operator that, that goes, where is it? On a number of time units, and then that's probably, what's this? This would be a postfix operator, that's the format, and then all of that is an argument to the operator use, which takes one argument, which is going to be a time format, because here it's a postfix operator. Format's a postfix operator, and it's marked with these kind of braces. So that means the value of this whole expression here is going to be a format or a time format. Yeah. Okay. So let me actually run this, and we'll see how the processing works, and then we'll come back here and look at the config. So anyway, this operator part, it defines the operators. Yeah, this defines the operators, or sorry, this defines the operators. And we'll go here. I was on that one. No. Yeah, okay, so let's run this node. What was I in? Time, use 24-hour format. So all the knowledge modules have this built-in, oh yeah, let me show that. The knowledge modules all have this built-in stuff they can do. Oh. There. So they can run the unit tests. So if I want to run the unit tests, I can do this. Or actually, I'm not demoing this. I did that in another one. Okay, so what I'm going to do is just demo what you see when you run use 24-hour time format and how you create semantics. So just okay. So if you have debugging on, it should. Where's all that junk? Oh, I didn't have debugging on. So the flag for debugging. Let's turn debugging on. Okay, so here it's going to dump out what I just showed you before, except it's way messier. So what I showed you before with the where it goes through, picks out the highest priority operator, then applies that and just does that until it runs out of stuff to do. So in this case, so what it first does is it starts out and builds a list of contexts, which a context is a property bag. So it just builds a list of property bags, and all you're doing is just combining the list of property bags until you get the answer. Right, so this is the start state. So use 24-hour format. This is what it ends up with. These are the operators. It could be constants here too, but these are all operators. Yeah, so these are, and you can see they're marked with the level 0. So these are all level 0 operators. What else do we have? And you can see the definitions here. This is in flux. I'm currently fixing this. It has like some legacy crap in it I'm getting rid of. Ultimately, it'll be just this part. Or sorry, just this part. So this is this to this side, it's the left side arguments, and the junk to this side is the right side arguments. So use takes a time format. This kind of matcher will match a time object of type time format. And then what count is also a prefix. Count is a prefix operator? No, count's a postfix operator that takes a time unit. No, it's a prefix operator. Oh yeah, use was a prefix operator. Count is also a prefix operator. And then in this one, time format is a postfix operator because that takes a time unit to the left side. Yeah. Okay, so anyway, so yeah, so that's all it does the first thing. So now we have to pick the operator. So what does it do? Here's the operator it picked. What did it? Units. So pick units, and it's just going to apply the operator units. So the reason it does this is it kind of acts like a type system. So I usually take concepts and map them as 0 argument operators. Like if you look at here, it should be 0. Yeah, time unit's a 0 argument operator. So it actually turns out it works like a type system. I didn't really design it that way, but it works that way. Anyway, so it's applied, it's chosen the operator time unit and applied it to get time unit 1. And so then what's happened here is it took this context here, right? And once you decide to apply the time unit 0 operator, you need to have some semantics that go and map it to the next value. So in this case, it's mapped it. The only change here is it's mapped it to the next operator. So now what we'll go do and look at is where that's defined. So if we go look in the source file, there's these things called bridges. I was kind of imagining the context like little islands, and you have these bridges that take the little island to the next little island. So here's the bridge for time unit, the one we just looked at, and level 0. And the only thing it does is it gets the next, it spreads the next value of the operator into the current context. So that's why over here, where is it? It went to 1. So here it's level 1 of the operator, and here it's level 0. Okay, so it's just doing what I did when I demoed it before. So we got here. So then all it does is it's applied time unit. So we pick the next operator. So what next operator does it pick? Count. So it goes and applies count. So count is this one here. And it has one argument, which is this one. So those two contexts are given to the count bridge. so that it can calculate the next one. And so what it's decided to do is do this kind of junk. And you can see that the time unit is still the value of the phrase. So applying count just really added these properties. So now let's go look at how that manifests over here. So count is here. When you apply the count operator here, it's going to be pass through. And so what's the result? How do you calculate the new context? Well, you take the junk after and spread it into the count. And then I think I have a helper for if there's no, I would have expected to see this, but I think I have a helper that does it if you don't do that, you forget to do that. And then it just sets the count value to the operator. So when you're in these bridge things, there's some special names. There's before, there's after, and there's operator. So operator is the operator being applied. Before is the list of things before, and operator is the list of things, or after is a list of things after. And so you can access those when you're generating your new context. So that's the application of a count operator. So then we get this stuff. So then the next move is to pick out another operator. In this case, it's going to pick time format 0 and apply that operator. So then we get, so here we had 3 contexts: use, time unit, and time format. Now we're going to apply time format and get the next level of the argument. So we switch, or the operator. So we switch from level 0 to level 1, and you can see the context has some more stuff in it. So if we go look at the bridges over here, you can see how that's done. Which one was that applying? Time format. This one. So time format. So it takes this stuff before, just spreads it in, and then I spread in the current operator so I can set the operator. You can do what you want here. It's kind of like JSON notation. I have my own parser on the Python side, so it doesn't, you can't do arbitrary JSON or EMCA script, but it does good stuff. Okay, so then that's applied. So then we do the next, we just pick the next operator again. So here we are. So this one is selected as use is going to be the next operator selected. And when it applies it, we end up with just one context. So we went from the 2 contexts to the 1. And the result of applying use becomes use level 1. So we can go over here and look at the bridges, and you see use is here. So what did it do? Spread the current operator in because it's not a pass-through, and just set the format to whatever the junk after is, and it's an array. So again, then you have after, before, and operator here. Okay, so at that point, that's all running on the server side. So then it comes back to the client side. So let's look here. All that logging I just showed you is from the server side, but this is what it gets back. So then after it gets back from the server side is it runs the client side semantics. Yeah, maybe the server side would be called bridges too, but I didn't. And so in here, the purpose of the client side semantics is because you can have way more complicated control here, because you can write arbitrary JavaScript, so you can have functions and stuff, access your own database. I didn't want to put that on the server side because then you need connectivity stuff. So this, okay, so basically we ran this thing with operator precedence parser, produced this as our interpretation. So now we're going to take this interpretation and we're going to understand it with our semantics on the client side, and then generate these paraphrases. So you can generate paraphrases. You can also, if you mark your, if you mark the context, the final context as a response, then it'll put a response string over here. I'm more using that for when there's an actual response, like when I say, you know, list the products, and then I want to see the products listed, but I also get the paraphrase. I want to show that. Reports, -q. So in this case, you have a paraphrase, which is what the person said. It takes the actual data structure that's generated in the interpretation and paraphrases that. And then the response is what you actually wanted as a response from this. This used 24-hour format. I didn't make it have a response. Anyway, so we've run the semantics. We've got this back from the server side. So what happens after that, or so we've run the query and got this back from the server side. So what happens after that is the semantics run on the client side. So the semantics sort of work like awk or CSS. There's sort of a matcher where it is used to select a context that you're going to run the semantics on, and then you have action, which is the thing you're going to do to that context. So there must be use. So here's use. Yeah, so here's a semantics. So the semantics for use is there's a bunch of arguments it gets. It gets this objects, the context, the config, a bunch of other stuff. Just, well, you can print them out because it's a hash. Anyway, so what I do here is check if the current context is use, it has a format set, and the context is 12 or 14. Then that's the matcher. So then the action is going to be in the object's data structure, set the format to be whatever the context, whatever the format is in the current context. So if we look at the current context, it's context.format.count. So context, this is the context that's returned from, or that's going into the semantics. No, this is the context that's going into the semantics. This is the context that comes out. Anyway, but they're the same looking. So it's going to pull format count, and it's going to stick it in the objects. This objects thing here, right? So that manifests like here, and then the other semantics are going to pull, if you say show the time, the other semantics are going to pull the context out of that format, or out of the context. Yeah, so here it is. So here's oh no, this is the paraphrase. Where is it getting it? Well, anyway, whatever. It's somewhere in here. It's getting the where's this object? Well, irrelevant. Okay, let me just skip saying that. Anyway, it can pull this out of the context. I'm just not seeing where it is at the moment. So when you say show the time, it can go if it doesn't have the time, it can go show the time based on the format it pulls out of this context. Good God, that must be in here somewhere. Objects dot. Oh, there it is. Sorry. Oh, I forgot. I was thinking I put it in the generators. Oh, I didn't talk about the generators. There's just a different semantics that pulls it out. So that's where it's getting pulled out. My brain is not malfunctioning. Okay, so at that point, it's run the semantics. So after it runs the semantics, the next thing it does is run the generators. And the generators, they're like awk and CSS again as well. They take a matcher, and then if the matcher matches, they will take whatever the context and convert it into a string. I mean, this is obviously a simple one. And there's two ways it'll run. One is it'll run with paraphrase set to true, and that's how it generates this sentence. So paraphrase set to true and response set to false, and that'll be in all of the context processed. So you can see here is where it's done the paraphrase one, where it's checked for a paraphrase is true. And then to get this response string, it'll only try and get this if the output context has response in it. And it will check, and then it'll just run paraphrase with context or with response equals true. This particular example doesn't have it, but if we look at the well, anyway, just take my word on it. I don't want to show this other knowledge module because it's a multi-API and very complicated. Anyway, so it'll call with response equals true, and that's how it's getting these strings that it shows here at the bottom, the paraphrase and the response string. So this may look like what I typed in, but it's actually generated off this junk. Yeah, it's interesting because I use it. If you look at the Fallout example, you can use it to generate different moods. So if like the person was angry, you could get them to paraphrase as an angry person instead of just like neutral. I showed that in one of the demos, or one of the like the Fallout demo, or the parping one. I can't remember. Yeah, so that's how. Oh yeah, so that's a whole run. of the system. So that shows how you, theoretical idea, how it relates to this notation here where you're defining operators and precedences. And then you can see over here, if you turn on debug, you get all this juicy information out of here. Yeah, where it shows how the operators are done. Really all it's doing is just starting out with a set of contexts, applying the operators. The result of applying the operator is just a new context. And ultimately you end up with a bunch of contexts, which then on the client side, you can, the contexts are made using, this is how you specify how to create a new context from the context passed to the operator. And then after that comes back from the server side, it runs the semantics, which sort of work like awk, and I guess awk is kind of an old reference, like CSS, where it has sort of a matcher, and then it has value, an applier that applies the value. And then after that's done, you get, again, you have a set of contexts, and then those contexts are passed into the generators in two different ways. One, it'll be with paraphrase equal true, and one if the context contains response, it will also set response equals true and generate that. And then I'll just show an example of response equals true. Yeah, so here's a paraphrase equal true, and then this is the response equal true because it's you're actually giving the user a response they want. Did I demo everything? And the generalizations are like operators can evaluate to another operator that it's a higher level. You can have this pass through or not pass through thing. And then there's, yeah, that's the main generalizations. And it actually can do like everything I've asked it to do so far. It's like, yes, sir, I can do that like right away. So it's really fun to program with because it's so easy. Like I'm used to natural language processing being like a giant pain in the ass. But this is easy to use. Yeah, so that's a high level demo, so I'm going to stop there.